Before starting, put the auto-generated YouTube subtitles in French or your mother tongue to get everything, and slow down or speed up the pace as needed. If you don't have time to watch it, just listen this video as a podcast while doing something else. Now listen and learn English as exploring our world. From the dawn of our species, we have gazed upon the stars, our ancestors mapping the heavens with primitive tools and boundless curiosity. They pondered a profound question that still captivates us today. Are we alone in this vast universe, or is there life beyond our blue planet? The cosmos, in its infinite expanse, holds countless planets, each with its own unique story, waiting to be discovered and understood. Could some of these distant worlds harbor life as we know it, or perhaps life forms that defy our very understanding of biology? Our search for extraterrestrial life begins right here on Earth, where we study the rich tapestry of life that thrives in every corner of our planet. Our own planet, teeming with biodiversity, offers a glimpse into the extraordinary adaptability of life itself, from the lush rainforests to the vibrant coral reefs. In the most extreme environments, from scorching deserts to icy plains, life finds a way, adapting to conditions that seem impossible. These harsh landscapes, often considered inhospitable, are home to organisms with remarkable resilience, showcasing the tenacity of life. These extremophiles, as they are known, thrive in conditions that would be deadly to most other life forms, pushing the boundaries of what we consider habitable. They offer tantalizing clues about the potential for life beyond Earth, suggesting that life could exist in places we once thought impossible. Join us now as we embark on a journey to explore the top 10 places on Earth where alien-like life could exist, ranked from least to most likely, each location more fascinating than the last. These extraordinary locations, each more extreme than the last, will challenge our understanding of life's boundaries and push the limits of our scientific knowledge, and ignite our imaginations about the possibilities that lie beyond our world, inspiring us to look to the stars with renewed wonder and curiosity. Our journey begins in the frozen south, in a place that could easily be mistaken for an alien landscape. The vast icy expanse stretches out as far as the eye can see, a testament to the raw, untamed beauty of nature. The Dry Valleys of Antarctica, one of the driest places on Earth, are a testament to the relentless forces of nature. These valleys are a stark contrast to the icy surroundings, with their barren, rocky terrain that seems almost otherworldly. Here, the wind howls across a barren expanse of rock and ice, seemingly devoid of life. The relentless gusts carve through the landscape, creating an eerie, desolate atmosphere that feels both haunting and mesmerizing. For centuries, this frozen desert was considered a sterile wasteland. The harsh conditions, with temperatures plummeting well below freezing and almost no precipitation, led many to believe that life could not possibly survive here. But recent discoveries have challenged this assumption, revealing a hidden world of microscopic life. Scientists, through meticulous research and exploration, have uncovered tiny organisms thriving in this seemingly inhospitable environment. Beneath the surface, in the cracks and crevices of rocks, tiny communities of microorganisms cling to existence. These resilient life forms have adapted to the extreme conditions, finding ways to survive where it seems impossible. These hardy microbes, known as endoliths, have evolved to survive in conditions of extreme dryness, cold, and ultraviolet radiation. Their ability to endure such harsh environments is a remarkable testament to the adaptability of life. They extract moisture from the air and nutrients from the sparse minerals around them, demonstrating the tenacity of life even in the most unforgiving environments. These tiny organisms are a beacon of hope, showing that life can find a way to persist against all odds. The dry valleys, with their stark resemblance to the Martian landscape, offer a unique testing ground for our understanding of extraterrestrial life. The similarities between these two environments provide valuable insights into how life might survive on other planets. If life can endure here in this frozen desert, it raises the tantalizing possibility that similar life forms could exist on Mars or other planets with comparable conditions. The discoveries made in the dry valleys not only expand our understanding of life on Earth, but also fuel our imagination about the potential for life beyond our planet. Our journey now takes us from the icy plains of Antarctica to the heart of the Amazon rainforest, a place teeming with life in its more familiar forms. But hidden deep within this lush green world lies a place of both beauty and danger, the boiling river. As its name suggests, this unique river reaches temperatures hot enough to kill most organisms. Steam rises from its surface as its waters, heated by geothermal activity deep within the earth, cascade over rocks and fallen trees. Yet even in this seemingly inhospitable environment, life finds a way. Within the scalding waters of the boiling river, thermophilic bacteria thrive, their resilience a testament to the adaptability of life itself. These heat-loving microorganisms have evolved unique adaptations that allow them to withstand temperatures that would be lethal to most other life forms. They provide a glimpse into the potential for life in extreme environments beyond Earth, where heat and geothermal activity are prevalent. Journeying deep beneath the surface of the Atlantic Ocean, some 700 meters down, we encounter a scene unlike any other on Earth. This is the Lost City Hydrothermal Field, a place where towering chimneys, some as tall as a 6-story building, spew forth warm, alkaline fluids into the cold, dark depths. Unlike the black smokers found at other hydrothermal vents, these chimneys are not formed by volcanic activity. Instead, they are built by a chemical reaction between seawater and the exposed mantle rock below, a process known as serpentinization. This reaction produces hydrogen and methane, gases that serve as the lifeblood of this extraordinary ecosystem. Here in the eternal darkness, devoid of sunlight, life persists. Thriving communities of microorganisms, completely independent of photosynthesis, have found a way to flourish. They harness energy from the chemical-rich fluids, converting them into sustenance in a process known as chemosynthesis. Few places on Earth can match the sheer hostility of the Dallol hydrothermal field in Ethiopia. This otherworldly landscape is a testament to the raw power and unyielding force of nature. Here, in the heart of the Danakil Depression, temperatures soar above 45 degrees Celsius, and the air hangs heavy with the pungent aroma of sulfur. The oppressive heat and the acrid smell create an environment that feels almost alien. This is one of the hottest and driest places on our planet, a landscape seemingly sculpted from the fires of Hades. The ground is cracked and parched, and steam vents hiss ominously, adding to the sense of desolation. Dallol is a riot of color, a testament to the powerful forces at work beneath our feet. The vibrant hues are a stark contrast to the barren surroundings, painting a surreal picture. Pools of vibrant green, yellow, and orange shimmer across the landscape, their hues a result of the extreme acidity and high mineral content of the water. These colors are not just for show, they indicate the presence of various minerals and chemicals. These are not your typical tranquil pools. They are cauldrons of boiling brine, their surfaces bubbling with escaping gases. The water is so acidic that it can burn skin on contact, making it a truly dangerous place. It's hard to imagine anything surviving in such an extreme environment, yet life finds a way. The resilience of life is astonishing, even in the most inhospitable conditions. Despite the searing heat, the high salinity, and the extreme acidity, scientists have discovered microorganisms eking out an existence in these toxic waters. These hardy organisms offer a glimpse into the incredible adaptability of life, thriving where it seems impossible. Flowing through the heart of southwestern Spain, the Rio Tinto presents a scene more reminiscent of Mars than Earth. Its waters, stained a deep blood red by dissolved iron, cut a dramatic swath through the landscape, a testament to the power of both geology and biology. The river's unique coloration is no accident. For millennia, mining activity in the region has exposed sulfide minerals to air and water, leading to the formation of sulfuric acid and the release of iron into the river system. This process, known as acid mine drainage, has created one of the most acidic rivers on Earth, with a pH level comparable to that of lemon juice. One might expect such an environment to be devoid of life, yet the Rio Tinto teems with microscopic inhabitants. Despite the high acidity and heavy metal content, a surprising diversity of microorganisms has adapted to thrive in this seemingly toxic environment. Deep beneath the sun-baked plains of South Africa, we embark on a journey into the heart of the earth. Our destination, the Mponeng Mine, a labyrinth of tunnels plunging more than 3 kilometers below the surface. Here, in the stifling darkness and crushing pressure, we might expect to find a barren wasteland, devoid of life. And yet, even in this most extreme of environments, life persists. This subterranean realm, seemingly inhospitable, is home to a remarkable bacterium known as Dilophorutis audaxviator. This tenacious microbe has carved out an existence entirely independent of the sun's energy, which fuels most life on our planet. Instead, Dilophorutis audaxviator draws its sustenance from the surrounding rocks themselves. It derives energy from the radioactive decay of uranium, a process that releases energy in the form of heat and particles. We descend now into the abyssal depths of our oceans, miles below the surface, where sunlight fades to perpetual darkness. Here, in this cold, unforgiving realm, we encounter a scene that seems to defy logic. A bustling oasis of life, teeming with strange and wonderful creatures. These are the deep-sea hydrothermal vents, fissures in the ocean floor where superheated, mineral-rich water spews forth from the Earth's interior. These vents, once thought to be barren wastelands, are now recognized as some of the most biologically productive ecosystems on our planet. The lifeblood of these extraordinary communities is not sunlight, but chemosynthesis. Microorganisms, the foundation of this unique food web, harness energy from the chemicals dissolved in the vent fluids, such as hydrogen sulfide. They convert these chemicals into organic matter, providing sustenance for a diverse array of creatures. Our journey now takes us to a hidden world, sealed off from the surface for millions of years, Movil Cave in Romania. Discovered by chance in 1986, this subterranean realm has remained isolated from the outside world for an astonishing 5.5 million years. Here, in the pitch-black depths of the cave, we find an ecosystem unlike any other on Earth. Deprived of sunlight and with an atmosphere toxic to most life forms, Movil Cave is a testament to the extraordinary resilience and adaptability of life. The air within Movil Cave is heavy with humidity and thick with carbon dioxide, methane, and hydrogen sulfide. Yet despite these seemingly inhospitable conditions, life flourishes. A unique community of creatures adapted to this toxic environment thrives in the cave's depths. Deep beneath the frozen wastelands of Antarctica, hidden from the sun and the biting winds, lies a network of over 400 subglacial lakes. These bodies of water, trapped beneath kilometers of ice, represent one of the most extreme and isolated habitats on our planet. For millions of years, these lakes have remained untouched by the outside world, their depths shrouded in darkness and mystery. Among the most well-known is Lake Vostok, a body of water the size of Lake Ontario, buried beneath over 2 miles of ice. The existence of these subglacial lakes was first proposed in the 1960s, but it wasn't until the 1990s that scientists were able to confirm their presence using radar and satellite imagery. This discovery sparked intense curiosity within the scientific community. Could life exist in such an extreme environment, deprived of sunlight and exposed to immense pressure? Stretching across 1,000 kilometers along the coast of South America, the Atacama Desert is a place of extremes. It is one of the driest, if not the driest, non-polar deserts on Earth, with some areas receiving less than 1 millimeter of rainfall per year. The landscape is stark and unforgiving, with towering sand dunes, salt flats that stretch as far as the eye can see, and volcanic peaks that pierce the clear, dry air. The Atacama's extreme aridity is due to a combination of factors, including its location between 2 mountain ranges, the Andes and the Chilean coastal range, which block moisture from both the Pacific Ocean and the Amazon rainforest. The air here is so dry that it can literally suck moisture out of your skin and lungs. Yet, Even in this seemingly barren wasteland, life finds a way. From the deepest mines to the harshest deserts, life on Earth has proven to be incredibly adaptable. These extreme environments, once thought to be barren wastelands, have revealed themselves to be teeming with life, albeit often hidden from our view. By studying these resilient organisms in the challenging environments they call home, we gain valuable insights into the potential for life to exist beyond Earth. What do you think? Which of these locations fascinates you the most? Share your thoughts in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more exciting discoveries. See you next time for another journey into the unknown.